So in this video, we'll discuss about that instruction cycle. So first of all, we'll define this instruction cycle, and after then we'll elaborate more about the instruction cycle with the help of example. So their definition is instruction cycle is defined as the time required to complete the execution of an instruction. In 8085, the instruction cycle consists of minimum of 1 to 6 machine cycle. So for example, let's say we are having an instruction that is called move C, A. So the operation performed by this instruction is copy the content of A register, that is called accumulator register, into the C register. So this is 1 byte instruction. This is 1 byte instruction, and that byte is called as a opcode only. So let's say this is stored at some memory location of 2000H in the memory system. So let's say it is here at this point. This is 2000H as their memory address, and their code as a move C, A. Let's say it is 4FH is stored here, so that is called their opcode. So this is 1 byte instruction. So whenever this will perform opcode fetching, then this 4FH data, it will goes from memory to the processor, and it will take 4T state to execute this instruction. So for the opcode fetch operation, the minimum time required is 4T state, or minimum number of T state required is 4T state. So to execute this instruction, it will take 4T state, and that is called, the operation is called as a opcode fetch operation. So this is referred here as a one machine cycle. This is called here as a one machine cycle, and here itself, by decoding and execution of this 4FH as a hex code from this memory to the processor, their entire operation is going to be completing. It means it is going to copy the content of accumulator into the C register, and by that way their execution will be completing. So it is taking one machine cycle, that is called as the opcode fetch, and for the opcode fetch here it is taking 4T state. So this 4T state is called the duration of this instruction cycle. So in 8085, the minimum number of operation is 1, and that is called opcode fetch operation. Opcode fetch operation is common to all the instructions, and that is the very first operation for any instruction in 8085. So here for this instruction, it is taking 4T state, that is called one machine cycle as a opcode fetch operation. But depending upon the instruction, it may have more than one machine cycle also. So this instruction cycle is not constant for all the instruction. So in this case, for this move C, A, their instruction cycle timing will be how much? Their instruction cycle timing will be 4T state, and as we know that this T state is equivalent to 1 clock period. 1 T state is equivalent to 1 clock period. So here this will take, the execution time for this instruction is T execution. It will be here as a 4 into clock duration. This is called clock duration or clock timing. So this much of time is required for the execution of this instruction. So their instruction cycle timing will be 4 clock period. So like that, we'll take another example here, that is MVI B, 7FH, and this is stored at somewhere at 2001H, and this is 2 byte instruction. So here, for example, let's say at this location at 2001H, it is having the opcode for this instruction. Opcode means the code, hex code for this MVIB. Let's say this as a XXH, and at the next location, that will be 2002H. At this point, it is going to store their next as a immediate operand as a 7FH. So 7FH is stored here. Now, whenever this instruction is going to be executed by this microprocessor, so this will take first opcode as a XXH, and after decoding and execution of this opcode, that processor is knowing that next byte will be the operand for this instruction. So it is accessing two memory space here. One is at 2001H and another one is at 2002H. So one operation is called accessing of this XXH as a opcode is called here as a opcode fetching operation, and accessing of this 7FH as a operand, so that is referred here as a memory read operation. So this instruction will take two machine cycle. One is called as a opcode fetch and another one is called as a memory read. So this is required two machine cycle, and for this opcode fetch it will take 4 T state, and for this memory read this will take here as a 3 T state. 3T state. So total it will take 7T state. So for this instruction, their execution timing or instruction cycle timing will be how much? This will be 7T state. Total T state will be 7T state here. So it means it is required 7 clock period for the execution of this instruction. So by this way, I hope you got the clarity about this instruction cycle. So instruction cycle is the time required for the complete execution of an instruction is called the instruction cycle timing. So here this is not fixed for all the instruction. It will differ from instruction to instruction, but minimum one machine cycle, or we can say that 4T state or 4 clock period is required for that instruction. It may be more than that depending upon that instruction operation as well as their number of machine cycle and number of T state required. So by this way it is clarified about this instruction cycle.